Hi YouTube, and today what I'm going to do is I'm just going to give you a very brief snippet on how to work out percentages when you are doing GCSE Chemistry, as it can be quite confusing, I think, for some students because they do a huge amount of percentage work at Key Stage 3. Anything ranging from what percentages are to calculating percentages, how to find percentage of amount using bar models, increasing amounts by a certain percentage. You can see there's a lot of different topics that one has to do at school level for percentages. So when they come into a GCSE science exam, for example, this is a question that I set my year 10s earlier this month, then there could be quite a little bit of confusion, especially and particularly if the GCSE chemistry question has a few extra added bonus new terms that can further confuse students. So I just thought, right, okay, let's nail this one because this should be something that is relatively easy, and I hope by watching this video I will make it a little more easier for you coming in as a viewer to work out percentages. So this is a question, it's actually from an Edexcel GCSE paper. The question talks about alloys, and this part of the question is referring to an alloy called magnesium. So magnesium, the question says, is a mixture of magnesium atoms and aluminium atoms, and the diagram shows a sample of magnesium. So the question then asks, how do you calculate the percentage of magnesium atoms in this sample? And the first thing that you need to do is make sure that you're counting the right atoms. So we can see that there are 3 magnesium atoms, and in total we have 4 plus 5 plus 4 plus 5, which is 18 atoms in total. Okay, so when you're working out a percentage of one type of atom as a whole collection of atoms, what you need to do is you need to figure out how many of those atoms you have. So read the question very carefully. It's not asking about percentage of aluminium atoms, it's calculating the percentage of magnesium atoms. So in this sample, in this picture, there are 3 magnesium atoms. What you then need to do is you need to have that as a representation of all of the atoms, okay, not just the aluminium atoms, but all of the atoms. So the calculation that you need to do, and I've got a cool science calculator, online calculator to show this, is you have 3, and what you need to do is you need to divide that 3 by the total number of atoms that you have, okay? So 3 divided by 18 comes out as 0.166666667 recurring, okay? Now in a calculator that will stay as something perhaps like, when you do your calculation, it may turn to it may stay as a fraction, but you can set your calculator in such a way that it just gives you decimals. I've got a video somewhere else on the channel. If you want to find it, just type in calculator in the search button, you'll find it. So what you then need to do is you've got this fraction, but you need to have a value that is a percentage. So to work out percentages, and let's just ignore any kind of percentage shortcut value that you have on the calculator. You could do that, but we're going to avoid that just for a moment. What you need to do is, if you just press return, if I just return, and then what I can do is I can then say 3 over 18 answer, if I just put that, multiplied by 100. Okay, that converts it to a number which is an actual percentage. So before we had a fraction, and now we actually have a percentage. Now, you will notice that this number is 16.66666 reoccurring. Okay, now there is a little clue right at the end over here as to what I'm hoping you will figure out. So with this number over here, you can express it as 16.66666 reoccurring, right? And then put the 7 right at the end. But it's more sensible to actually give it as a more everyday kind of figure. Okay, so in an everyday kind of figure, what you would need to do is perhaps go to a percentage which has 2 significant figures. So in that form, this answer would be 17%. Okay, and the reason why it's 17% is because the 6 on the right-hand side of the decimal point is bumping up the units value of the 6 on the left-hand side. So 16.6666 will then be rounded upwards to 17%. Now, at GCSE, that would be an acceptable way of giving your answer. If you wanted to go to one decimal place, you could do that. All you would need to do is you would need to write down 16 point, and then you look on the right hand side of that final number that you want to give. Is that number a 5 or above? If so, then the final number that you have, which is the 6 on the right hand side of the decimal point, will bump upwards to 7. If that number is 4 or below, the 6 will stay as a 6. So you wouldn't express this number as 16.6. You would express it as 16.7. Okay. All right. So that deals with rounding up and rounding down. All right. So to summarize, all you'll need to do is figure out the number of magnesium atoms you have, then divide it by the total number of atoms that you have. That includes magnesium and aluminium. And then with that fraction, multiply it by 100 and you get your answer. So your correct answer for this question is 17%. You could give 16.7%. You could give 16.67%. So long as you do the rounding, and in this question, make sure that you put your calculation there as well, because sometimes they will not be able to give you the mark if you haven't proven that you have gone through a percentage calculation. I hope that helps. Let me know if it helps. Leave some feedback, like and subscribe, the usual, and good luck with your exams. Take care. Bye.